This is a new way to build a RAG system and knowledge database in NN. It's a big upgrade from what we had before, and I'm going to share this template with you all for free. I'm going to show you how to take a regular PDF like Coca-Cola's earnings report and turn it into something your AI agent can understand, search, and answer questions about with real accuracy. This setup is what I called a new RAG stack, and here's why it's different. First, we use LlamaIndex. This tool does not just pull plain text from PDF. It actually understands tables, Markdown, JSON, images, etc. So instead of just copying and pasting text, we extract clean, organized data your AI can use. Then we store that in Pinecone. Pinecone is where all your info goes. It lets your AI search for the right answers quickly using something called vector search. Basically, it finds content that is similar in meaning, not just keywords. And here's something new. We're using a tool inside NN called Reranker. This helps your AI choose better answers by reordering the search results based on relevance. If your agent pulls in too many results, Reranker makes sure the best ones are used first. And finally, we measure everything. With NN's evaluation feature, we can actually test how well the system works. We give it real questions, check if the answers are correct, and see if Reranker can help to improve the result. So let's break it down. LlamaIndex helps us extract better data from PDFs. Pinecone stores and searches that data, and the new Reranker may help us improve the results, especially for large documents. Evaluation tells us what's working and what's not. So with this system, you get better answers, fewer mistakes, lower token costs, and actual proof that it's working. And the best part, no code at all. Just drag and drop like this. The full template is available in our free community, and you can just download this and upload to NN easily. If you're new here, my name is Andy, and I share easy-to-sell AI automation systems and NN tutorial like this every single week to help you kickstart your AI agency and quit your 9-to-5 job to pursue your dream. To help you achieve your goal, in our premium community, we offer a zero to hero NN course from beginner, intermediate, and advanced level. And also, we provide a comprehensive 6-month AI agency course designed to guide you from day zero, step by step, day by day, and week by week. You'll learn exactly how to build, launch, and grow your AI automation business from the ground up with clear actions, proven strategies, and real-world examples. And what even better is that you can get all our advanced and ready-to-sell templates here inside our template section as well. You can find all the templates here. And if you want technical support, we've got you here in our community as well. We make sure that all your technical problems are solved so that you can implement our templates easily. If you want one-on-one help getting this running, we've got you covered as well. So let's dive into this new RAG system, and I'm going to go through the notes one by one. Let's get started. Hi everyone, so today I'm going to teach you how to set up a RAG database in NN, and we are going to use some of the newer features. So the first one is LlamaIndex, which allows you to extract the text content from PDFs to improve the precision of your RAG system. The second one is a new feature in NN called Reranker, so you can actually get more accurate answers and reduce token usage. Then the third one is how to use the NN evaluation feature to determine whether applying the Reranker actually improves your results or not. And of course, Reranker is a very new feature in NN, and it doesn't yet have a lot of customizable settings, so sometimes it may even reduce performance. So that's why we also cover how to use the evaluate function and note to analyze the result. Of course, Reranker is a very new feature in NN. It does not yet have a lot of customizable settings, so sometimes it may even reduce performance, and that's why we will also cover how to evaluate and analyze results. Alright, so let's jump into the tutorial. In the first section, we'll teach you how to set up your vector database. The first tool we'll use is LlamaIndex. We'll also use the cloud service, LlamaCloud. So LlamaIndex is a document retrieval tool that allows you to accurately extract text from documents like PDFs and save that into your vector store. And why don't we just copy and paste the text from a PDF? So for example, today we are using a PDF document, Coca-Cola's Q1 2025 earnings report. You see it has a lot of text, but also tables. If you just copy and paste the tables, you will not be able to accurately extract the table structures. In that case, we need to use the PDF extractor. And there are so many PDF extractor available, and OpenAI also provides one through its assistant feature. But using it requires uploading documents through a more complex process. So we are going to teach you how you can use LlamaCloud's simple API to upload a PDF, extract its content, including well-formatted tables, and return it as text. And this is the first tool we'll use, right? And the second tool we're going to use is Pinecone Factor Store. In NN, there are many factor store. You can search for like Supabase, Postgres, and MongoDB. Today we will be using Pinecone, which is a more established and easy to use factor store. It also connects easily with embedding tools and has chunkers and data splitters features as well. Okay, so now let's get started with the first part. First, we need a trigger here, okay? So this is a trigger node. This trigger can be replaced by other tools like Google Drive or Google Sheets. So what we are using is a menu trigger, for example. So when a document is added, it will run a workflow to insert it into your factor store. But to keep it simple today, we just use a document URL with this edit field node. Say I found this report and I want to upload this to my factor store. I will copy the URL and then paste to this document URL field. Once I have replaced the URL, NIN will automatically download the document. Okay, so let's execute the first step. After setting up the URL, we'll send a PDF to LlamaIndex. You can look at LlamaIndex documentation. So we can go to docs.cloud.llamaindex.ai to see how to handle file uploads. So for this tutorial, we'll only use one part of this parsing feature. So for the first step, we are going to upload a file. So we are going to send a post request to the upload endpoint. Then for authentication, just go to your LlamaIndex Cloud dashboard. You can go to here. And then on the bottom left, you'll find the API keys button. We can generate a new API key, name it, okay, and then we can actually create a key, then copy that key, okay, and then we can go back here. So you can see that we have the authorization header and also the barrier before the API token. Okay, and so we can go back. So we can actually click this header auth. You can actually create new credential, but we have created already, so I can show you here. For the name, we can put authorization, and then for the value, we are going to add the prefix barrier space. Okay, then you can actually go back to the API key and copy that and paste it here. Okay, so that's how it works. So once the header is set, once the authentication are completed. So next step, for the upload document endpoint, you just need to input a simple document, either a file object or an input URL. It supports different types of functionality. You can input directly from S3 or use an input URL. And this time we use the simplest method, which is using form data. Here you can see that the accepted format is form data, multi-part form data. We need to select form data and input URL and drag the document URL from the previous step here. Okay, so that we can actually set up this request. Okay, so now we can actually try to execute this step. Okay, once we upload this, it will return an ID and an endpoint. We can clearly see that in the parsing history. One more document entry has been added here. Okay. After the document is uploaded, we need to wait for the back end to perform parsing. We set it around 60-second waiting time. Each document has a different length, so we can adjust the wait time accordingly. So in this case, we just wait for 60 seconds. Okay, once the waiting time is over, we can move to the next get results step. It will check inside the document for get drop result. Alright, so for get job result, there are many types. For example, if we go to the cloud and look at this record here, okay, and on the right hand side you'll see it as many different result formats. For example, it can have a markdown result where it highlights the titles and tables are returned in table format. There's also a text result here where it returns plain text. It also has JSON or image results. For example, any images extracted from the document will be returned here. Okay, this time we only need one result, which is the markdown result, because markdown handles tables more completely and clearly, making it easier for our factor database to process them. So when using the get job result endpoint, we'll use the get job raw MD result endpoint. We can copy and paste it to our next get result node. Okay, we can use this HTTP request and then we can actually paste it here. Okay, and for this JSON ID, it means it's referring to the previous node. We can drag and drop the ID here. Okay, so we are going to use the entire result and use the previous parts document to get the result here. Don't forget to set a header here, the authorization. And once we execute this step, this one, we'll get a complete result back, and it will return the entire PDF content in markdown format under this data key. Okay, so the next step, we're going to input the document to the Pinecone factor store. We can choose this Pinecone factor store node and we can select insert document. And then after opening a Pinecone account here, so we can actually create an index. Okay, and we need to pay attention here to choose the corresponding embedding model, because this embedding model will affect the configuration settings in NN. Different embedding models will have different max token input and dimension settings. For example, if we're using this OpenAI's text embedding 3 large model, we need to select a dimension of 3072. This dimension is already defined in the embedding model, so we must match that configuration. And below that, you can choose the cloud provider and region, which will affect the pricing as well. Once everything is configured, we can go back to your factor store and you will see your settings here. Okay, back in NM, simply select the corresponding configured factor store here that we just created, and the credentials also need to be connected to your Pinecone account here. So how we can set up a Pinecone account is very simple. We can go back to Pinecone. On the left, there is an API key section where you can generate the needed API key and put it to the NN credentials here. Okay, so once all that is set up, there are two more options you can actually configure. Okay. One is the embedding chunk size. If you are concerned your PDF document is too large, you can set a limit, for example, 200 or 1000. The embedding depends on your chunk size. The second thing is, since we are doing testing, we'll clear all content from a database every time we upload, so that we can keep uploading new data without being affected by the previous data. Next, we configure a namespace. So what exactly is a namespace? It allows us to set different categories in a single factors database. For example, one for Google quarterly reports, and other for Pepsi reports, etc. When we do the query, we can actually separate them. So in this case, since all the reports are finance related, we just call the namespace finance. Okay, once you configure this node, there are two things that need to be connected. Okay, the first is the embedding model. As mentioned earlier, the embedding model you select in Pinecone must match the embedding model you configure here in NN. For example, if we use OpenAI's text embedding 3 large model, since its dimension is 3072, we must choose the same model here. Choosing a different model would result in inaccurate results or input errors. Then the second is the document loader. Since the factor store might not understand how to handle the uploaded document, we need to specify this. For example, if our extracted data is stored under the key data, then we must set that path here. Okay, you can also assign metadata or add additional properties. In this case, we're not using metadata. We are going to remove this. Okay. Then under the data loader section, we are going to attach a data splitter. Okay. So a typical PDF document can have anywhere from 1,000 to 10,000 words. Every factor store has a different optimal chunk size. You can check research or test different chunking strategies. So let's take a look at this. For this test, we'll set the chunk size to 1,000, meaning each 1,000 characters will be one entry stored in our factor store. We'll also set an overlap of 50 characters before and after each chunk. We can also use another method called split by code. And since our input data is in Markdown, we can use Markdown based splitting to avoid breaking important terms or structures like operating income, mid-sentence, which would lower accuracy. So using Markdown to split gives clean chunks. Okay. Once everything is ready, we can actually run this factor store node. And you will see it calling the data loader and the embedding model to chunk, then store the data. So if we go to Pinecone, okay, and then you can see all the records here. Okay. Okay, so this completes the first part, which is parsing PDF content into text and storing it in the vector database. Okay. Okay, next is the main workflow. The core idea is like a chatbot. You will see a chat trigger here that connects to an AI agent here. Okay, the AI agent connects to a chat model and also queries the Pinecone factor store. Then the workflow returns a response. And above that, there is a separate branch for evaluation. This helps you assess whether your prompts or factor store settings are effective or not. We first go through the basic lower half from chat message to AI agent. So we can start with a chat trigger, this one. AI agent setup is very simple. We can actually connect to a chat model this time. Okay, this one. And we're going to use GPT-4 as our chat model. Then we are actually use the tool and connect with the Pinecone factor store. Okay, the factor store tool actually auto connects to the selected account and factor store that you set early. For example, we have NN demo tool. Once connected, you add a description for this tool. Okay, this one. For telling the agent this tool helps retrieve financial reports. Okay, so that's not complicated. And there are two more optional settings here. First is the metadata. If you previously assigned metadata like page number or other properties, you could extract it here as well. But we didn't use it this time, so we can disable that. And then the second one is the new NN feature called Reranker. For now, we can actually leave it off because we're going to compare that later. We're going to use that later. Next, we must set the namespace here, same as what we configured earlier. This ensures the search is scoped to the correct database. Okay, and after that, connect the correct embedding model again, same as the one used during document upload. In this case, OpenAI text embedding 3 large. Okay. Once everything is configured, we can actually click open chat and we can type hello. Okay, if it is a normal chat function, it won't give any response or perform any update. So you see that a pure chat function is actually very simple. For example, if we ask a very basic question like hello, it will not go to the factor store to look for a result. On the other hand, if we ask something related to content of our report, it will automatically perform a search from the factor store. For example, if we ask what is the global unit case volume grew in 2025. Okay. Because it's related to a financial report, you see that it triggers the Pinecone factor store here. And it will find a corresponding result here. So how do we check if the result from the factor store is accurate? We can actually open this and see that it retrieved 10 records. And what are these 10 records? The agent will actually formulate a search keyword. For example, for the question I just asked, it will automatically look for the keyword global unique case volume 2025 to do the search. Since we actually selected a limit of 10, it will return 10 results from the vector store. So if I change the limit to 1 and ask the same question again, okay, let's do it again. Okay, so we can see there's just one result here, just one item. And in contrast, retrieving just one item might not be accurate, so it might not return the correct answer. That's why we recommend when connecting to the vector store to retrieve around 5 to 10 results. This will provide a more accurate set of references for the AI agent to determine which answer is most accurate to use in response. Just now we mentioned the node called Reranker. In some situation, let's say we retrieve 10 to 20 results, which is like a larger amount, and sometimes when Pinecone for the store does a query or the embedding model runs a query, the result may not be very accurate. In that case, we can actually use Reranker, and currently AndyNoCode supports Cohere Reranker. Once we have connected this, it will take the 10 limited results we retrieved and parse them to another model called the Cohere Reranker model to perform re-ranking action. Okay, the setup of the Cohere Reranker model is very simple. You just go to Cohere's AI website. Okay, this one, and then go to your account. And on the site, we can see the API keys. Generate your API key. Then we can input the key name, and then we can actually copy this API key and go to the credentials here and paste it here. Okay, so that's how you can set up this Cohere Reranker. After you set up the Reranker, you can actually run the same question again. So let's try to ask the question again. What is the growth rate in 2025? Okay, so you will see it automatically triggers the Reranker here to run. So what the Reranker does is it takes the 10 results we got earlier and uses another model to compute the relevance score between your question and the content retrieved from the vector store. For example, maybe the closest segment has a score of 0.85, and the second closest is around 0.75. It will reorder which segments are most relevant to use for answering a question and pass them back to the vector store. Okay, then return the result to the AI agent. So the final answer will be optimized and using the Reranker. Okay, but currently this Reranker does not have many configuration options. You can only input and it only returns 3 results to you. So when we are actually setting up the vector store, the limit must be more than 3 results. That way it can provide enough reference for the Reranker to pass to the AI agent. Because it lacks configuration options, not every model is suitable for using the Reranker. Let's say you only fed one PDF document in and it already gives accurate result, then there's no need to use a Reranker. Okay. And how do we determine whether we should connect new functions like Reranker? We can actually use another feature of AndyNoCode called evaluation, which is the section above. So the evaluation setup goes like this. First, we set up a Google Sheet to hold evaluation questions. For example, we put 10 questions inside this Google Sheet. Let's take a look at this. Okay. For example, we input 10 questions inside Google Sheet. Then we expect that for these 10 questions, the AI agent should return specific answers. Then we will have 4 empty columns here. The first one is the relevance score, which we can use the AI agent to calculate whether the retrieved results from the vector store are accurate. This helps us assess whether the vector store query is good enough. We're able to later calculate whether the results got better or worse after using the Reranker. Okay. Then the second one is correctness score. This is comparing the AI agent's answer against our expected answer. And then this one is a summary explaining why that score was given. Or this one is also a reference AI answer to show what the AI responded with. Okay, so we can actually go back here. First, we need to place a note called evaluation trigger note. Okay, trigger, this one. This is the one. Okay, so after we place this evaluation trigger note, we can actually move on to the second step. We can run it to get the chat input and the expected answer here. Okay, so we can actually run this workflow first. Okay, so when it grabs the first question, we can actually go to the next node, this one. The first row, we can actually see it contain the question and expected answer. So we first set this to chat input, so the next AI answer node can directly read the chat input. We'll also include the expected answer, so the upcoming node can compare it. Okay. All right. The next node connects to the AI agent here. Then for the prompt here, it was same as the one we used with the chat input. Because we already set chat inputs as input, everything here can use the previously defined new message. Okay. When we run the AI agent node, like this, it will automatically take the earlier question and produce an AI agent answer. And we can see this answer appears under the output section. Then the next node determines whether we are running a chat input or an evaluation. Since this time we are running evaluation, the subsequent nodes will have more steps to run. Okay. Next, we need to extract the intermediate steps from the AI agent. This intermediate step is a setting inside the AI agent node, and which is returning intermediate steps. So in the AI agent, there's a function called return intermediate step. If we do not enable this, you will see that it reduces some of the results. It will not return the data retrieved from the vector store in the output, so you only see a single answer as output. When we enable this return intermediate steps, it will include the data retrieved from the vector store in the output, which makes it easier for us to do the next step, evaluation. Okay, so for example here, you will see that it retrieves the observation data from the vector store. Then we can actually go to the next node, which is extract documents. This is another edit field nodes. We can actually organize the output here. We'll extract the portion of intermediate steps that relates to the Pinecone vector store node. It will retrieve the first result, so we can modify it to retrieve all results, okay, related to Pinecone for evaluation. Okay, nice. So once we execute this step, we will see these are all relevant documents retrieved from Pinecone. This time, because we are still connected to Cohere, you see the result shows 3 relevant documents retrieved via Cohere. Okay, this is the Cohere node. Okay, next we move to another node. This is an evaluation node. It calculates whether the document retrieved and the AI's answer are accurate. Inside, we have split this into 2 parts. The first part is a system message. So we pass in the question, the expected answers, also the facts here like this, which are the relevant documents retrieved. Inside, we ask it to do 2 things. First, a relevance evaluation to calculate whether the documents retrieved were relevant. Then a score of 0 means completely irrelevant, and 1 means completely accurate. And scores in between are automatically calculated based on relevance. Then the second part is Cohere evaluation. It measures how accurate the AI answer is compared to the expected answer. At the end, it will provide reasoning summary and also the relevance scores and also correctness score. Okay. Then the second message, the user message, is where we pass the question, expected answers and AI answers, and the facts as well. So you'll see that this time we asked a question expecting an answer like 11.1 billion, 2% decline. The AI answer might vary. You'll also see what relevant documents are retrieved here. So using this, the evaluation AI can compute how accurate this run was. For example, This time it might say the AI provided the correct data and document, but not in a very detailed way. So the relevance score is 0.8, and also the correctness score is 0.8. Once we have this data, we can set 2 more evaluation nodes. What are these 2 nodes? You can find them in the evaluation tab as well, and you can search for here. Okay, they're called set metrics and set outputs. The set metrics node is where you can configure how to calculate batch evaluation results later. It uses these scores to compare an overall average. Okay, so this is the set metrics node. You can see this relevance score, correctness score. Next is the set output node. This connects to a Google Sheet. So this is a Google Sheet, and this finance tab, we left spaces earlier for relevance scores, correctness score, summary, and AI answer. It works similarly to the update Google Sheet node in NN. We just need to configure which columns get which answers. Then we can actually execute these 2 nodes, okay, and this one as well. Okay, so we can see the evaluation results will be updated directly to the Google Sheet. So for example, 0.8 for relevance score and 0.8 for correctness score, and a summary explaining the score along with the AI answer. Okay, so in this scenario, we have now completed the full evaluation workflow setup, and now we can compare whether enabling Reranker gives better or worse results. To run the evaluation, we first save it first here. Then in NN, under the tab called Evaluations, we find a button called Run Test, this one. When we click this Run Test, okay, it will send those 10 questions and answers into the previously created workflow and run it once to get the relevance scores and correctness scores. Okay, and let's try to run it once. Okay, after running, you can click inside to view the results. You see that it ran 10 tests. For each of these 10 tests, it shows how many tokens were used, including the number of completion tokens, prompt tokens, and the total token counts. We can use this data to optimize, for example, how to reduce token usage while maintaining a good answer. Then it also shows the execution time, relevance score, and correctness score. At the top, there's also an overall average score. For example, this time the documents we retrieved only had around 0.71 for relevance score, and the answers had about 0.63 for correctness score. So with this information, we can run a second round of evaluation. So this time we can go back to the editor, turn off the Reranker feature, and return to the evaluation tab to run the tests again. So after the second run, we observe something different. The total token usage has increased a lot. For example, last time it was only 700 to 1,000 tokens, but this time the total tokens are much higher. Why? Because without using Cohere's Reranker, every time we return 10 relevant documents instead of just 3. But another difference is that the relevance score is significantly higher, and that is the document we retrieved this time almost 100% accurate, and the answer reached a 95% accuracy score. So in this case, we can say that actually we didn't need the Reranker. Accuracy was even better without this. In this data set of document and the specific set of questions and expected answers, Reranker isn't suitable. That's because we only loaded one PDF document and the questions are all directly related to the content of the document. So in this situation, Reranker has very little impact. So when is Reranker useful? Let's say we ingest the entire Coca-Cola website, all their social media and all other relevant materials, and in one go we are returning a massive number of documents, many of which are unrelated. In that case, Reranker might help the effective store return better or more precise results. Or in the future, if Reranker is able to return more than 3 documents to the AI agent, it might improve the output accuracy. So in this case, we really need to use the evaluation function to help decide whether you use Reranker. And apart from helping you decide whether to use a particular tool, evaluation is also helpful for tuning other settings. So for example, how to set the chunk size, how to set the overlap, and how to configure the AI agent's prompting. All of these settings affect how well the chatbot or AI agent answers. Okay, we can use evaluation to fine-tune each time. For instance, whether to make the system prompt longer or shorter, or add more instructions to guide the AI agent on how to process content. All these can influence the answers returned by the AI agent. So that's the end of this tutorial. We taught you how to use LlamaIndex for building a vector store, how to configure Reranker, and finally how to use evaluation for fine-tuning your entire AI agent pipeline to get the best possible results. All right, so let me know what you think about this tutorial in the comment section below, and feel free to let me know if you encounter any technical questions in our community. I will see you in our next video.